So if we recall back the previous problem, we see that the solution of this problem has ended up as x equal to 3 by 2 plus or minus I root 7 by 2. So this leads to a complex number, as I mentioned, and the general form of a complex number is z equal to x plus iy. So this is the standard form of any complex number, whereby the x value is the real part, which we can write it as rp, and the y value is known as the imaginary part, which can write it as ip. So therefore, the complex number generally comprises of two parts. One is the real part and the other one is the imaginary part of any problem. Remember, the I is the notation of an imaginary part. That's a very important thing for us to understand in any case. Now, since we have seen the definition of a complex number and the standard form, now let us see how a powers of I is identified. We know that I square equal to minus 1. So therefore, that can help us to find out that I is nothing but square root of minus 1. Now, similar to that, we can say that I cube can be written as the power 2 plus 1, whereby we can split using the index concept, that I square times I. And since we know that I square equal to minus 1 from the earlier definition, so we can summarize this and write it as minus I. So similarly, we can also say that I power 4 is equivalent to I square times I square. So I square again is equal to minus 1, therefore minus 1 times minus 1 will be 1. Now from here we can say that in any cases, any power of I that we have can be summarized as I minus 1 minus I and 1. So if we look at it, it has two real value, two imaginary value. That is, one is minus 1, the other one is 1. These are the two real values. The other one is, it can be I or minus I. So let us see some example. If it is I power 5, then we can summarize I power 5 as I power 4 times 1 plus 1. Now the reason why I have taken 4 is we know that I power 4 is the largest value, and in any cases we are going to make use of the division of 4 for any number. So therefore I power 4 times 1 plus 1 will give you the value 5. So now I can say I power 4 power 1 times I power 1 using this value here, using the concept of exponential form. So now this I power 4 is equal to 1, 1 power 1 times I will lead to I. That's the value of the I power 5. Let us see another example. Simplify I power 59. So how can we write 59 in any form? So let us write the 59 in a proper form of division by 4. Say, let us see the solution. 59 can be written as 14 as a value that we get it after having the remainder 3. Therefore, we can say the quotient is 14, the remainder is 3. So therefore, in simple we can write 59 is equivalent to 4 times 14 plus 3. Therefore, if we know that 59 can be written as this format, therefore we can say I power 59 is equivalent to I power 4 times 14 plus 3. So therefore, we can summarize that using the power format as I power 4 power 14 times with I power 3. Thus, this will give us the value by substitution, that 1 power 14 times minus I, because I power 3 is equal to minus I power 4 is equal to 1. So this will lead us to 1 times minus I, and finally I power 59 is equivalent to minus I. So this helps us to solve the power of any number. So this is the second part that we have. So the moment we know the power of i's, now we can go for any computation of the problems, and the I is very important when we solving any other problems later part. So let us now see the next part, the computation of a complex number. The computation of a complex number can take place like this. If z1 equal to x1 plus i1, z2 is equivalent to x2 plus i2, then the addition of any two complex number can be given as x1 plus x2 as the real value, y1 plus y2 times the I would be the imaginary value. Similarly, let us see how the subtraction of complex number takes place. Now this is basically nothing but the subtraction of the real part and the subtraction of the imaginary part, and then we solve it accordingly. Take note, the solution of any complex number is a complex number. Let us see some example. Evaluate, given that z1 equal to 3 plus 4i and z2 equal to minus 2 plus i, evaluate z1 minus 2 z2 is the problem. So how do we solve it? Now if z1 minus z2 is given to you, all we got to do is, in simple manner, substitute the value as it is. Then we expand it by multiplying the minus 2 inside, we get the value as plus 4 minus 2i. Now gather the real values together, that is here, then gather all the imaginary values together and simplify the value. So now we can see that the z1 minus 2z2 equal to 7 plus 2i. So take note, the computation of any complex number is another complex number. That's very important. Let us see now the part of multiplication. If z1 equal to x1 plus i1 and z2 equal to x2 plus iy2 is again taken, then let us see how the complex part of the multiplication takes place. Now if z1 and z2 is given, all we got to do is, like how we multiply any algebraic form, we multiply these values also. So now here I expand it one by one by taking the x1 and multiply this entire value, so therefore I have it in this format. Next taking iy1 and multiplying the entire value here and expand it. So now when I expand it, I will get it as x1 x2 times with x1 with this value iy2, similarly of this value. Now take note, there is an I square existing in the multiplication. This is where the power of I is used. Therefore when we simplify, we get the value I square become minus 1. So now this entire value become a real value. So therefore when we simplify this, we get that the z1 z2 is equivalent to x1 x2 minus y1 y2 as the real part, plus I times x1 y2 plus y1 times x2 as the imaginary part. Now this is a formula wise identifying the complex number. However, let us see an example. Say if we are given that z equal to 2 plus 3i and w is given as 5 minus 2i, but we are supposed to find out the z times w. This is multiplication of two complex numbers. Let us see how we can compute this step by step. Just write down the value of z and w together. Take the value of 2 and multiply the value, similarly 3i and multiply the value on the right hand side. So we get the simplification 10 minus 4i plus 15i minus 6i squared. So once we have this, take note again, I square is there. So therefore this, when we substitute as minus 1, we get it as this value, and simplified further we get it as plus 6. Therefore, now plus 6 and plus 10 is a real value. Therefore, we can summarize the entire value as 16 plus 11i.